Hello. Today we are going to talk about how to draw cyclohexane ring flips. Let's say we are given a left-leaning chair with a methyl group in the axial up position and want to draw its right-leaning conformation. First, we should label all the carbons in the ring. I personally like to use numbers, but we can use letters or any other symbol to keep track of where our carbons and side groups are going to end up after the chair flip. Next, we draw the skeleton of the right-leaning version of the chair. Then, we need to label the carbons on this right-leaning conformation. I only labeled it one way, but there are three ways we can label this chair. Think of this ring as being comprised of hills and valleys. Each carbon in the ring is either in a valley or on a hill. After the chair flip, the carbons in the valley end up on the hill, while the carbons on the hill end up in the valley. So they essentially flip places, but the relative positions of the carbons need to stay the same, or else we would be making a different molecule. For example, the number 1 carbon is initially on a hill. That means we can place it in any one of the valleys after the chair flip. After identifying the location of one carbon, we can label all the other carbons according to their relative positions to the first one. For instance, since we know that the number 6 carbon is initially in the valley a step counterclockwise to the first carbon, it should be placed on a hill a step counterclockwise to the first carbon after the chair flip. Now that we have labeled both our chairs, we can start to add on axial and equatorial groups. Understand these two main things when flipping. First, all axial groups become equatorial, and all equatorial groups become axial. Second, all up groups remain up, and all down groups remain down. With these in mind, we know that axial up leads to equatorial up, and axial down leads to equatorial down, etc. So here we start with an axial up methyl group on the number 1 carbon. This means that we should end up with an equatorial up methyl group on the number 1 carbon after the chair flip. Here are two other ways we can draw it. If we labeled the carbons differently at the beginning, as you can see, the methyl group always ends up in the equatorial position after the chair flip because it started out axial up. The carbon also ends up in the valley when it started on the hill. Just make sure to keep all the other carbons in the same relative position. Lastly, here are the links that I used to help me understand these concepts, and they may be of help to you.